Hi students, coming to the next topic, direct memory access. Here, the memory access, our aim is to access the memory. What is meant by access? Generally, we are going to call either read data or write data. Read or write. If you want to perform either read operation or write operation, that is simply it is called access. So from where we are going to accessing this read and write operations based on the memory locations. That means inside memory locations, sometimes we are reading the data, we are writing the data. So what is meant by direct access? Direct access through this memory. That means direct memory access. So generally what will happen initially, here CPU and memory always connected with bus configurations, that is bidirectional data bus and control bus. That means address bus and data bus and control buses. That is CPU and this is memory. CPU and memory. This is CPU. Suppose if CPU is always generates some address through this address bus to select one location in the memory. After selection, with the help of this control line or control signals, we are going to reading the data from that location, and that location data is placed into the data bus. Data bus will carry like this, and it is transferred to the inside CPU for the data. Inside CPU, that CPU will process the data. So next one, suppose if you want to transfer the data from CPU to memory, same analysis. Which location if you want to transfer? That means suppose if you want to transfer to this location, again place the address on the address bus. Address bus will carries like this and points one location in the memory. After highlighting this location or after pointing this location, this control signal will generate the control. That means control signal is called write signal. If you want to read signal is generated. In this case, we are going to write in some data from CPU to memory. So that here control signal is carries write signal. If it is received, that time this data is read from the CPU and placed into this data bus. This data bus is carries the information and is placed inside right inside the memory locations. So actually the CPU always deals with data transfer in between memory. That means transfer in between CPU to memory, memory to CPU. Sometimes is IO devices needs to transfer some information into the memory. Sometimes IO devices needs to transfer information to the memory, or sometimes IO devices needs to receive the information from the memory. So if the situation is like this, in some cases, suppose if IO device needs to transfer from this place to this place, very less amount of information. That time the CPU is take the complete initiation of the transfer technique. With the help of the CPU command signals, this IO device will transfer the data and it is stored inside the memory location. This is not a problem. So suppose if IO devices has some bulk of information, what will happen? Bulk of information in the sense IO device, some disk drive controllers, magnetic drums, magnetic disks, magnetic tapes are there. So if the type of IO devices has some bulk of information or excess of information or very high information is there. If information is more, that time the data accessing speed through this memory with the help of all these buses is that means memory accessing speed, that means data accessing speed is very slow. So if that situation will comes, automatically CPU is performing previously with any other processor. That means CPU is processing with other tasks. That time the data until the transfer is completed, CPU operation will be slow. So if the CPU operation is slow, automatically data transfer operation is also slow, because CPU of operation purpose, the CPU will use all these three buses, and also these three buses are sometimes used to transfer of the IO device to memory location. So if the CPU is not a position to control the speed operation from IO device to memory, that time IO device is requesting one more device to handle the operation. The device is called a DMA controller. This is very important. That means DMA controller. IO devices is requesting one more device, that means one more controller device, that is a DMA controller. Please handle this operation. With the help of this DMA controller, without involvement of the CPU, DMA controller is directly access IO devices to memory, so that the speed of operation is very high. Without involvement of the DPU, processor is handle this operation. The accessing speed of the data is very slow. So to overcome that situation, DMA controller will comes into the picture. It will handles the operation to speed up the process, the data transfer in between IO devices to memory or memory device to IO devices. So that time IO device is requesting some service to DMA. DMA is take over the complete control of all the buses. This is the way we are going to initiate the DMA controller. Here the importance of the DMA: whenever the IO device needs to transfer bulk of information or large information or excess of information, that time this DMA controller comes into the picture. Otherwise, no need of this DMA controller for transfer of the IO data into memory or IO memory into IO. So that means if the DMA controller comes into the picture, we are going to disconnect the complete involvement of this CPU. If the CPU is disconnected from this complete data transfer, that means directly we are transferring IO data to memory. So if directly transfer, so that memory we are going to accessing directly. So that the directly accessing memory is called as simply it is called access the direct memory or direct memory access. That means without involvement of the CPU, we are accessing the memory data directly with the help of DMA controller. That is called a direct memory access. In this case, this is the CPU bus signals for DMA controller. That means what are the signals we are receiving from the CPU? Suppose if DMA controller comes into the picture, what are the signals we are going to initiate to control this DMA initially? So here CPU bus signals for DMA transfer: bus request and bus grant. This bus request, bus grant signal is connected to this is DMA. Suppose DMA is requesting some service, that means bus request. That time CPU will provide some bus, all the buses initially. So as per this analysis, initially I will draw the block once again. This is very important point. This is memory and CPU. Initially the data bus and address bus and control bus. This is address bus and data bus and control bus. These three buses is connected with memory and it will handle the operation. So without involvement of the DMA controller. If DMA comes into the picture, the CPU is disable all the buses connections from the memory. That means disconnected from all the connections from the memory. These disconnected buses, that means address, data, control lines are connected to the DMA operation. So in this case, here DMA is requesting some service. Please provide some buses for the transfer, IO transfer. That time it is requesting some service to the CPU. So previously these four buses, that means address bus, A bus, D bus, data bus and read and write signal is nothing but control signals. These three bus connections is permanently connected to the memory initially. But if bus request signal is received, that time DMA releases the connections from the memory. These three buses are connected to the DMA controller. After providing the service based on this request, this CPU will gives the one more acknowledgement signal, that means bus granted. Previously DMA is asking some request, so that CPU is responded, that means releases the connections from the memory. The released connections is connected to DMA controller. Now DMA controller is take over all the control of the all the buses. Now there is no involvement of the CPU involvement of the on these buses, that means address data controls. Now it is freeing from the control of the all these buses. Now DMA controller is controlling the all these buses. After providing these three buses, the CPU will provides one more acknowledgement signal to the DMA, that means bus is granted. So this is the way we are going to transfer the data from IO device to memory or memory to IO device. So in this case, we are going to identify here two important points are here. DMA burst. DMA burst indicates, suppose if you want to transfer from the IO devices, if you want to transfer, here assume same analysis, IO device, from IO devices to memory. The block of data consisting a number of memory words is transferred at a time. So how much memory is there inside IO devices? The complete information at a time you transfer inside the memory location, that is called DMA burst. That means this transfer is under controlling of the DMA. This transfer is under control of the DMA. Here cycle stealing means DMA transfer one data word at a time, after which it must return control to the buses to the CPU. That means suppose at a time we are going to transfer one word of information. Memory number of locations are there. That means this has some limited locations. That means depends upon the address decoder, these locations are countable. So depends upon the location size. At a time you are going to transfer, at a time all the data is transferred to memory, that is called DMA burst. Suppose if you want to transfer one byte at a time, that is called cycle stealing. So generally cycle stealing operation is nothing but a CPU has a more CPU, that means CPU handles a more accessing cycles. So that means mission cycles and instruction cycles like this. It has some cycles, that means operation cycles are there compared to DMA. Suppose if you want to transfer one byte from IO device to memory, that time DMA is received some cycles from CPU to DMA. If DMA is received some cycles, that time CPU is processing with another task. That means CPU is process another information that time. But the CPU operation is very slow. Whenever the DMA is received or taken some cycles from the CPU, that time one byte of information or one word of information at a time you are going to transfer. One word of transfer is completed. Again the control is take back to the CPU. Next DMA is receiving cycles from the CPU. Again this one word of transfer is taken from transfer from IO device to DMA. Again the control is take back to the CPU. Again it is cycles are receiving from the DMA, it will perform. So that means every day, every word transfer, the DMA is received the cycles, that access cycles from the CPU. So that time if it is received some cycles from the CPU, accessing speed, that's accessing speed of the or processing capacity of the CPU will be decreases. That means the operation speed is decreases. If the operation speed is decreases, the CPU accessing speed is decreases. DMA controller takes more operation cycles from the CPU, and it will control the operation of the IO data transfer. That is called the cycle stealing. That means DMA controller is received more cycles from the CPU for data transfer of the IO to memory. That is called cycle stealing. In this case, DMA transfer one data word at a time, after which it must return control of the buses to the CPU. So next one, here in this case, the block diagram of the DMA controller. This is very, very important. In this DMA controller, we are going to identify the registers and control logics. First of all, here internal bus is connected internally with all the registers and all the control logics. this internal bus or system bus. We are going to say that this internal bus or system bus. That means system bus is nothing but address bus, data bus, control bus. These single buses consist of inside address, data and control buses. That means this bus carries all the binary values. Here address register and word count register, control register. So this register is called as a data bus buffers. That means address bus buffers. Data bus buffers means always it holds the temporary data values. Address bus buffers always it holds the temporary address values. Data bus buffer values received through this data bus. Address bus buffer values are taken by the address bus. So coming to these three registers, the points are very, very important. Address register. Whenever DMA is enabled, that time this initial address of the memory. That means the memory has some addresses are there, number of locations are there. Each location has some address. So whenever the control is taken by this DMA controller, that means CPU releases the connections and the control is given to the DMA controller. That time it will provide initial address. First of all, it will provide initial address. That address is stored inside the address register. That means CPU will provide the starting address or initial address of the memory location. Next one, word count register. Word count register means how many words of the locations or how many words inside that location, that memory. That means this is a one word or simply it is called one location. How many locations are there or how many words are there? That complete count is number of count value will stored inside the word count register. So coming to this controller, after this DMA is taking control of all the buses, this DMA controller will generate the control signals with association of the control register. That means a control register always maintain the status of the mode of transfer. That means mode of transfer means control register will maintain the status of the mode of control. That means write transfer or read transfer. Write transfer in the sense we are going to writing some data into the memory location from the IO devices, outside IO devices to memory locations. That is called write transfer. Suppose if you want to read the data from the memory location to the IO devices, that is called read transfer. The type of control transfer mode control signals binary values will hold by the control register. Once again I repeat, address register always which holds the starting or initial address of the memory location, and this address is provided by the CPU. Word count register holds the number of locations in the memory count or number of words in the memory. That count is held by the count register. This control register is always holds the status of the mode of transfer, write transfer or read transfer. Coming to the another point, address bus buffer. Every byte of transfer or every word of transfer from IO devices to memory, automatically address incremented by 1. Again, the one more word is transferred inside the memory location. If transfer is completed, address is incremented by 1. That 1 byte of transfer goes into the memory location. It is stored. Again, after completion of the word transfer, again address is incremented by 1. Address incremented by 1 more word is transferred to the memory location. Like this is the way we are going to transmit. Every time address is incremented. So this address is incremented by 1. That value will stored inside the address bus. That address bus buffer always holds the current address of the location, where the data is transferred from IO devices to memory, or where the data is received from the location. That location address is held by the address bus buffer. This address bus buffer is sent through this bus, and this address is used to selection of the memory location. So this is the way we are going to using all these registers. So suppose if you want to, whenever CPU reads the data of any one of the register, address register, word count register, control register, that values are connected through this data, this bidirectional buses, through the system bus. All the bidirectional is nothing but a system bus. Through the system bus, we are receiving the data values. The data values are transferred through this data bus buffer and data bus buffer to CPU. So coming to the control logic. In this case, control logic is control the entire environment of this hardware. How this will control? That means DMA select. DMA select means, so CPU is released the connections complete 3 buses, that time DMA comes into the picture. Whenever DMA is enabled, that time this DMA select is goes to 1. If it is goes to logic 1, that means this DMA controller is a present case, it is a enabled state. That means it will comes into the picture, it will take over the complete control of the all the buses. Register select, that means which register we are going to select, the type of status is selected. That means register transfer or IO transfer. The type of status is held by this one. If it is a register transfer, that time it is equal to 1. So if it is equal to 0, that means that is a memory transfer or IO transfer, IO to memory or memory to IO transfer. That time the type of transfer is carried by using register select. And coming to the read and write signals, whenever the read transfer or write transfer, the mode of transfer control bits hold by the control register. If read signal is generated, that read control status hold by control register. That means write signal is generated, we are going to writing some data inside the memory location. The read signal is generated, we are reading some data content to the IO devices. Reading the data and placed on the data bus will carries, and it is placed into the inside the IO location, IO devices. Bus request and bus grant. So here bus request and bus grant is directly connected to the CPU. From the previous analysis, this is CPU. Bus requesting, that means please provide me all the buses like this. Please provide me all the data control address buses to for IO transfer, that data transfer from the IO device to memory location. The type of request is sent from this DMA to CPU. After providing all the buses, CPU will gives one more controls acknowledgement signal, bus grant signal. So this type of two control signals are we are going to consider here inside control logic. So coming to the interrupt, whenever IO transfer is completely completed, that means transfer in between IO to memory, the complete transfer is completed, that time one more interrupt signal is given to the CPU, because the transfer is completed. That time this that is interrupt signal is sends from this DMA to CPU. That means CPU will understand that the transfer is completed. Whenever the transfer is completed, CPU is releases the bus grant signal. That means if it is releases the bus grant signals, means that DMA controller is releases the 3 bus configurations, address data control. Now it is control is taken by the CPU. All the 3 buses control is taken by the CPU. Now DMA is free that time. So that time bus request is no need of the bus request. So coming to this one, from the IO devices, suppose if bulk of information is there, that information for high speed of accessing purpose, this IO device is requesting the DMA. Because if it is a very less information or very 1 byte of information, the type of transfer, no need of this DMA controller. If bulk of information is there inside IO devices, magnetic drums, magnetic tapes and magnetic disks, so that the bulk of information always needs fast accessing speed, so that IO device is requesting some service to the DMA controller. Whenever it is request, that time DMA controller is requesting through this bus request to the CPU. After providing all the buses to the DMA controller, again this DMA controller sends back to the acknowledgement, DMA acknowledgement. Previously it is asking some request to provide all the buses. Now after receiving all the connections from the CPU, after disconnecting the CPU, that time this DMA controller gives one more acknowledgement to the IO devices. That means DMA controllers take over the complete control of the all 3 buses. That time the IO device will understand the now this IO device is ready to transfer, because DMA controller is control all the buses. This is the way we are going to transfer the data from IO devices to memory initially. Suppose if you want to transfer from memory to IO devices, that time memory to IO transfer is possible. Thank you.